Hi guys, welcome to my channel. So we are just doing the laws of motion chapter, and today we are going to study about rocket propulsion. So rocket propulsion. So this is based on momentum conservation. Okay, conservation of momentum. Conservation of momentum. Okay. So initially let the mass of the rocket, so initially at time t equals to 0, let the mass of the rocket be m naught, and let v naught be its velocity. Means v naught is equals to 0, means there is no, means the rocket is not still flying. Now after some time, so now the rocket is filled with fuel, and and after some time the fuel starts combusting, and the fuel after combustion the gases come out of a nozzle with high velocity. So to conserve the momentum, the rocket also gains a velocity, okay, and it starts moving upward. So let at time t let the mass be m, and let the velocity be v, okay, and let the velocity be v. So now what we are going to do, let a small amount of mass dm, okay, suppose at after time dt means t equals to t plus dt, the mass decreases by dm. That means the fuel, that is the mass of the fuel that is burnt is dm. So the mass of the rocket decreases by dm, and the velocity increases by f, means dv. As the mass decreases, the velocity keeps on increasing, okay. So now here you see the exhaust gas is moving in this direction. Let its relative velocity with respect to the ground be vg. Okay, so by using the principle of conservation of momentum, we can, okay, in the first case let us just neglect if we neglect this escape velocity, and we just consider it that if we neglect this small amount of mass that is burnt out, and if we just consider here this mass into velocity, okay, so by applying conservation of momentum, we can say that in this case the momentum of the rocket is mv, and in this case the momentum is m minus dm v plus dv, and in this here, okay, here now dm is the mass of the gas that is burnt, and vg is the mass of is the velocity of this burnt out gas. So burnt out gas, so vg is in the opposite direction of v plus dv, so we add a negative sign here. Now just simply just solving, we can write it like this. So as these two, the dm and dv both are small, so the product of them is also very small and negligible, so we can neglect it. So we can write it like mv plus mdv minus dm v plus vg. Now mv from both sides is cancelled, then we can write that mdv equals to v plus vg dm, right. So now we have to find the relative velocity of this gas with respect to the rocket. The relative velocity of the gas with respect to the rocket is, the velocity of the rocket is v and the velocity of the gas is vg. So relative velocity of the gas with respect to the rocket is this. Okay, is this. Now now as both are moving in opposite direction, so we have to consider this negative as vg. I have added here, I have added the negative sign here also. Here means as vg and v are in opposite direction, so we have to write it like this. We have to consider this sign. So we can write it, the relative velocity of the exhaust gas with respect to the rocket is this. So now, so let this be equals to u. So Vg plus V is equals to minus u. From this we can write. So mdv equals to minus u dm. So substituting the value here, we get this. Okay. So now just bring m here and just integrate both sides. So in the first, initially the velocity was v naught, after time t it's v. Initially the mass was m naught, after time t it's m. So we can write it like this. So v minus v naught equals to minus u log e m minus, it's log e m minus log e m naught. So we can write it like this, minus u log e m by m naught. Now if we just means this, if we can write it like this also, the negative sign is omitted and this is just reversed endlessly. So velocity at any instant is v equals to v naught plus u log e m naught by m. So we got this. Okay. Now if v naught is 0, then v equals to u log e m naught by m. We can write it like this also, because initially the velocity v naught is 0. So we got this these expressions. Okay. So from this we can say that the velocity of the rocket at any instant is directly proportional to the velocity of the exhaust gas and directly proportional to the natural logarithm of the ratio of initial mass by mass at that instant. Okay, initial mass to the mass of that mass at that instant. Okay, from this we can just say that v is directly proportional to u and v is directly proportional to log e m naught by m. Now what is burnt out? What is burnt out speed of the rocket? Burnt out speed is the maximum speed that the rocket can attain. Means all the fuel is burned, and after all the fuel is burned, let the residual mass be mr. Okay. Then what? Let the burnt out speed be vb. So we can write vb equals to v naught plus u log e m naught by mr. So this is the burnt out speed. Now what is thrust on the rocket? Thrust is the upward force with which the rocket is moving. So we got an expression here, this we got this now. Now just write it again here, mdv equals to minus u dm. Now let us divide both sides by small interval of time dt. So we can write it like this. So dv by dt is a, we know, acceleration. Now ma equals to force, so F equals to minus u dm by dt. This is the upthrust with which the rocket is moving upwards. Now in these cases we just neglected gravity, but if we want to add gravity to this phenomena also, then we can do it. The expressions will change, okay. Okay, if we consider gravity, then force will be this, force will be this. So this force will act in the upward direction and the weight will act in the downward direction. So the net force will be u. If we consider just the magnitude, this sign is of no use actually. We added it because this is in we got it in the earlier expression due to the opposite direction of exhaust gases velocity and the rocket's velocity. So we can neglect it and we can write it F equals to u dm by dt. So when we consider gravity also, so if the rocket is moving with a force upwards and its weight is acting downwards, then the net force is this, right? And one more thing, if we want to find the acceleration of the rocket at any time, so we can do it. Just we have to divide both sides by m, because F equals to ma. So if we just divide both sides by m, so we can write it like this. So m, now what is m? M is the mass of the rocket at that instant. So mass of the rocket is what? Initial mass minus dm by dt, means that rate of consumption of fuel into the time. So at that up to that time, this much of fuel is just combust, and the rate that and the mass, residual mass of the rocket is this m. So we can just write it like, just we can substitute the value here. You're getting it, right? Just थोड़ा ध्यान दो तुम लोग यहाँ पर, okay? Just concentrate here. Means I divided both sides by m, so here m is cancelled. So I could keep here m, but I just made it more elaborate. I just derived an expression of m, then I could put it here, okay. So we can find, okay, now let us see and study about equilibrium of concurrent forces. Equilibrium of concurrent forces. What are concurrent forces? So we don't know this now. Let us study it. So rocket propulsion is done. Now we are going to go through equilibrium of concurrent forces. So what are concurrent forces? First of all, we have to know that. The forces acting at a point. Suppose this is the point. Here F1 is acting here, F2 is acting here, F3 is acting here. The forces which act at a single point are called concurrent forces, okay. And when, despite of the acting of the force at this point, the point is in its original state, it is in a state of rest or it is in a state of uniform motion, okay. So we can say that the point is in equilibrium. So the forces are not causing any problem, so they are just not disturbing the system. So this is called equilibrium of concurrent forces, okay. Means that the vector sum of the forces is 0. So here F1 and F2 is like this. So suppose we have to find the vector sum of this. So we can see that if vector sum of this is in this direction, so these two cancel out, and there is no resultant force acting. So this is equilibrium condition of this point. Now what is Lami's theorem? We are moving to our next topic. Is Lami's theorem, that is important for solving problems. So we can use this Lami's theorem for solving problems. Now we know we know what is called law of sines, right? From trigonometry we got to know it. So in a triangle, suppose let us say that this side is A, this side is B, and this side is C, and this angles are, means this angle is A, this angle is B, and this angle is C. So from sines law we can say that A by sine A equals to B by sine B equals to C by sine C. Very simple derivation, very simple, not at all difficult. You can easily do it. Okay, this is sines law. So now we are moving to Lami's theorem. What is Lami's theorem? Let us consider here three forces acting at a point. This is one force, this is another force, and this is another force. Okay, let the point be O. Let the forces be F1, F2, and F3. Let the angle between F2 and F3 be alpha, and let the angle between F1 and F2 be gamma, and let the angle between F1 and F3 be beta. Now we can arrange the three forces in the form of a triangle, closed triangle. How can we do so? Just this is the force F3 in this direction. Here we can write it, this is the force F1 in this direction, and this is the force F2 in this direction. You just arrange it. F3, F2, this is F1. Now just extend these things. Okay, extend these things. So I told you already the angle between here, the angle between F2 and F3, F2 and F3. So this is F2 and F3. The angle between this is alpha. Angle between F1 and F2, F1 and F2. It's F1 and F2 is gamma, and angle between F1 and F3, F1 and F3 is beta. So here we can write it as pi minus gamma, pi minus beta, pi minus alpha. So we can just applying sines law, we can write it like this: F1 by sine pi minus alpha equals to F2 by sine pi minus beta, F3 by sine pi minus gamma. Now sines law means that the ratio of this side by the sine of the opposite angle equals to ratio of this side by sine of its opposite angle equals to ratio of this side by sine of its opposite angle. So we just applied it here, and we know that this remains as sine alpha, sine beta, and 3 by sine gamma. So this is the Lami's theorem. Hope you enjoyed the video. So continue watching these videos so that you can easily understand this chapter. And in the next video we are going to study about motion of connected objects. So okay, if you like the video, hit the like button. Don't forget to subscribe to my channel and keep watching my videos and keep supporting me. Okay, thank you.